there are a ton of PlayStation 4s out there. I don't remember the exact number. But this is shipping in the fall, and it's actually quite good. This unit runs between 60 frames per second and 120 frames per second. And then, of course, HoloLens. So HoloLens is a sealed device. It's a computer. It's the whole AR experience on your head. It has a 40-degree field of view. I haven't got the chance to play with it. I'm going to try to jump the line and jump right in there. I haven't seen one in the real life. I just talk about it a lot. It's really cool. I think what we're going to find is that VR and AR are going to come together, and we're going to see mixed reality kind of be what really happens with these technologies converging as this gets further along. The second one I want to talk about is one that was shown at CES. This is Meta 2. I haven't seen this, so I talked to a guy named Reverend Kyle. In the VR community, we have a lot of personalities. And so we have a Reverend. He is a real Reverend, by the way, so I'm just stealing the name. He runs a VR podcast, and he was at our meetup last night via Skype, and he was talking about his experience with both HoloLens, because he has one, and this device. This is actually tethered, and they've managed to get the field of view a little bit wider. So there are more and more players, and I guess I should mention Magic Leap. We don't know what it is. Can't wait to see it. There you go. That's all it is. So that's the hardware. The good news is with the exception of PlayStation VR, all of it's shipping right now. You can actually have VR at home. So let me see your hands. How many people have VR at home now? Gear VR? Is it Gear VR? Oculus Rift? That one's the hardest one to get. HTC Vive? Sweet. You know, actually, if you go to the meetup, I'll rant more about that since we're at a Google event. I want to see them do something great, and what I do like the infrastructure. I like where they're going, and I think they're positioned to actually really own it if they did it right. It'd be really nice not to have a Samsung proprietary solution. So if they do what I hope they do, it should be really exciting. So I'm going to talk a little bit about Oculus and HTC Vive. I'm not going to talk about how come Facebook, and it's not about Facebook. I'm going to talk a little bit about the hardware and what separates them today. All of this stuff is moving really fast, from the software and the hardware. So what I tell you today won't be true too long. So as it stands right now, tracking is done with what they call the Constellation Tracking System. And essentially, it's a camera that looks at IR infrared lights that are inside the headset and tracks it. It's very similar to motion capture. When they release the touch controllers at the end of the year, or when you see it back here, because we have them, you'll see a second camera added, and the second camera will watch both the controllers and the headset. So it's possible with those two cameras, if you have a long enough USB connection, to do room scale stuff. And there's been a couple of examples of this shown on the internet. If you follow the Reddits, there's been a war that's been started, which is unfortunate, where we got the Vive people and the Oculus people, and we're all kind of like, oh, mine's better. It's all like the PC and Mac wars, it's the same kind of thing. But in the end, VR is what it's about, and they're both great. The second system is the HTC Vive Valve system, which is the second way of doing tracking. What's really cool about this is that they're using, and of course this is cool, laser beams are cool. Two boxes that are just connected to the wall. They're not connected to the computer at all. They emit lasers in there from both sides, and the headset actually picks up, similar to GPS, where it's located in the space. So there's a little ARM processor inside the headset that says, here's my data, and so over a little USB cable, it goes back to the computer. Unlike the Oculus system, where the Oculus requires the PC to process the video to figure out where you are. So, if you've done mobile, you do all this stuff, it's always the same story. Think about your idea. I'm going to take it a little bit further than that. VR is really an interesting thing, and I think the first thing people try to do is create the real world in VR. I don't know why that is, but we do this all the time. So I started a project at Market. We were going to do a virtual trading floor. And so the first idea is, let's remake Wall Street. Let's make that room. And I was like, oh, sorry, the Samsung watch heard me say something I have no wall. This thing hears everything. And so they said, well, let's rebuild the real trading room. And I was like, no, because it won't really be as good as the real thing. What you should think about when you think about doing VR applications, in my opinion, is think about what you're trying to achieve. What is it you're trying to learn? So like in the case of the financial space, we want to look at data and try to find ways to look at data to learn about things to help us invest better. So we're looking for patterns, right? So we still did kind of make a virtual trading floor, but we didn't model it after the real thing. I'll show you a slide that shows a picture of it, though it's not very good. So think about your idea, think about what you're trying to achieve, and let the idea be what carries you, not the coolness of the tech, because the coolness of the tech just gets you a really cool demo. So, desktop or mobile, HTC Vive or Oculus Rift, Gear VR or Cardboard, these are decisions you have to make, and there are a lot of interesting results of these decisions. Now, the best thing I've ever heard is that if you're thinking about VR for everyone, if you target mobile, you pick the hardest route, but you also pick the route that'll work on everything in the end. So you need to make these decisions a little bit based on who your users are going to be. So your engine, which one should you use? Well, the truth is there's really two that are really being predominantly used, and really just one if you think about mobile. So Unity 3D is pretty much the one people are using for doing all the mobile VR, all the Gear VR stuff. I'm not going to say Unreal Engine can't do it, but I will say you will be in a very open desert, trying to get the performance and trying to get the help you need to make it happen. Unreal Engine's very pretty, makes really nice stuff, but I think it's mostly desktop. I mentioned CryEngine just so in case there's some CryEngine guy in the back. I'll mention Torque 3D in case there's somebody in here. So that's incomplete. So this is a Unity layout. This is actually the project I was working on. When you run the app, I dynamically draw heat maps in 3D space, and the user can move around the space. And on the top of each of the sectors in the financial area, so you have the technology sector, home, discretionary, all this stuff, you can look up, and there are video panels on the top, and you can watch videos for those relevant sections. Very cool demo. Very cool demo as well. This is the Unreal Engine UI. This is not something I made. I wish I did. It's very nice. Seriously, you can get away with a lot with, especially if you use Blueprints, which is their scripting, visual scripting engine. So you can not write code, but if you do need to write code, you're talking C++. Unity is C#. So you have SDK choices. So Oculus would like you to use their SDK. The friendly folks at Steam said, let's support both. Of course, Steam is a little bit, Valve's a little tricky. They've got 130 million users on Steam. They're not trying to build a store. So they can be open and, let everybody have our stuff, where Oculus is very much trying to build a platform. So right now, the development community is a little bit split. A lot of us are doing OpenVR, SteamVR, so that we can make both platforms work. So I want to talk a little bit about assets. One of the things I learned when I started doing a VR project is that I needed to make really good friends with my 3D artist. And partly because we needed to agree on some things. Now, I wish I had known some of what I'm about to tell you before I started. The first thing you need to agree upon is scale. It's really easy to say, just make me this object and I'll take it into Unity, I'll make it whatever size I want. But if suddenly you have a ton of objects you have to do this for, it becomes quite the task. So agreeing that 1 unit is equal to 1 meter, or whatever that measurement is incredibly important. Related to this is a lot of times we don't think about the audio that you need, the music, the video, all the assets. Trying to collect these and trying to get these things at a low enough polygon level so that you can get the frame rate is critically important. Related to that is source control. So who here is using Git? Git is great, right? Until you throw Unity at it. It's not so great. So there's something called Unity Annex, which somebody told me about, but I haven't had time to check out. It might solve the problem I'm talking about. Well, the way Git works today, it basically doesn't deal with binaries very well. So my project, which really didn't have that much art in it, quickly ate up the 2 gigabytes of space I had on the bitbucket.org. So I don't have a good solution for this. A lot of people that are doing game development do not use Git. They use other, like PenForce or some other things that handle these things better. Or they don't check in the binaries for the images in the art. I did find a free solution that might be interesting to you. Visual Studio Online. They give you all the space you want. They just limit the number of developers before you have to pay. But it's unlimited space, so that's what I did for the short term. Project considerations, painful facts in developing a virtual reality. So, okay, how many people have a copy of this book? I think my team does. I certainly should have a copy. So this is one of the things that doesn't work so well in VR, particularly if you pick Unreal Engine. There is no Stack Overflow article about, oh, my frame rate's dropped to 20. I don't know what's wrong. What do I do? And copy this code in, and it's all better. So the truth is, the way we do it now is there are communities. So on the Oculus forums, on the Oculus VR site, the subreddits, and there's a Slack VR devs that's really good, where the real developers are. So it's a little harder. This is not all baked stuff. Not all the solutions are out there for every problem. We don't actually understand how to do locomotion right. We don't understand a lot of things about user interface. It's not like, it's a little bit like the mobile days were in the very beginning. I'm going to talk about scale, but I'm going to talk about it from a little bit different perspective than he did. Scale is something you have to actually think about from the point of view of you're building an application. Let's say you have a child in the application. What's the right thing? You're building a room, and there's a table in the room. Do you want the child to experience the table at the site, at the level that they really are, right, for short? Or do you want the room to scale to the person? So when you're doing room scale VR, you have to make these kind of considerations. You have to think about, one, what is the physical space of the room I'm in, and do I scale to that? Or do I have a much bigger area and I allow the user to teleport across the room? So you have to think about locomotion. You have to think about the representation of your assets to your users. And then coming back to performance, this is probably the hardest problem, because we can make really beautiful things, but getting a high frame rate isn't easy. Actually, do you see my little box over there? Oh, yeah. Yeah, I carried it over here. Sorry. I'm going to show you a 0 frames per second. Okay, here, let me pass this around real quick. This is a stereoscope. This, because of this, we have VR. Basically, there are 2 images, 1 per eye, and each one you have to render from 2 different perspectives, and you have to do it at 90 frames per second. And I'm almost out of time, so let me. This is VR today. We're doing 2K per eye. Where we want to be is at 16K, and look at the performance you need. So the video card manufacturers are thrilled. This is about tracking. I can talk more about that in fact, how it works. So this is the Vive system with the laser trackers. And this is about teleporting, and it's my last slide. So in teleporting, you have a bigger space that you can actually walk in, point to the ground, create a target, and you appear over there. The space gets moved. And there you go. Again, Colorado VR, we meet once a month. We have a really active group. It's really cool, a lot of good guys. And that's my thing.